Welcome to the second episode of Tech Innovator Season 5, organized by IEEE TechVerse Sri Lanka. Today we are going to explore about what you need to know before starting your career. Is AI replacing your first tech job? I am Chamali, your host for the day. Our topic is something that flips the traditional tech career path on its head from coder to commander. With AI automating much of the hands-on coding work, is the role of a junior developer becoming obsolete? Could we see internships for tech leads instead of associate software engineers? To explore this, today we have invited this outstanding personality, Dr. Chathuranga Hettiarachchi, a senior lecturer and a research assistant in computer science and engineering at the University of Moratuwa. With the PhD from Nanyang Technological University in Singapore and also an engineering degree from University of Moratuwa itself, he blends a strong academic roots with global research exposure. On behalf of the IEEE TechVerse Sri Lanka, I warmly welcome you for today's episode.
Thank you, Chamali, for the invitation. Thank you, TechVerse, for organizing this, and thank you for the opportunity. So, looking forward to answer some of your questions.
Let's start with this. In your view, how has AI changed what a first job looks like for new developers today?
Okay, so so first of all, we are at a kind of turning point of development of entire civilizations, right? So you know that the steam engine and the finding of maybe the gunpowder, right, has drastically changed how the world is evolving and how the civilization is evolving over the time. And of course, we are at an exponential development path, right? So you know that it took people to master fire maybe thousands of years, but to master the steam engine and the vehicles, right? Modern vehicles, it took only maybe 200 years. The electricity, again, similar number of years. But now we are at a venue that we are mastering the skill of artificial intelligence, right? So with that, we are seeing a large number of changes coming into our lives. But at the same time, we need to be able to cope up with it, right? So the world is demanding us to keep it up with the trends, right? So how do we do that? So that's the main challenge we have to face today. So I'm from computer science background, so I have been studying this for a while, and the idea is that, of course, during last recent couple of years, you know that AI has been disrupting the industry in a significant way. So, but how can we gauge it first? Then only we can actually realize and try to cater and adapt to that changes. So first of all, now you know that the internet, right? Internet disrupted the large number of industries during maybe a couple of decades back. Then again, there was a idea and understanding about something called a internet bubble, right? So internet was enabling a lot of things. At the same time, it was probably hyped too much, right? So a lot of investment, a lot of people gained a lot of wealth through that. But again, a lot of promises were not sometimes met. But there was, obviously there was a significant number of enabling capacity was also there, right? Various different disruptive applications have been enabled. So similarly, now we have to think about the AI. Is it just a hype, or is it really going to disrupt our lives, and how do we adapt, right? So the first thing it seems to be is that it can do coding, right? Of course, it can answer questions, and then by improving on top of that, you can do coding. So indeed, it seems that there are a lot of capacity there and potential there. But as engineers, now what are you going to do, right? So the first thing is that, of course, there are fundamental ideas, like as students, right? As undergraduates, probably the major thing is to master the basic skills, right? Basic skills of solving problems. So that's the foundation of everything. Engineering is about solving problems and how to approach a problem properly, right? So toward that end, I think your skills development, how do you analyze a problem from the scratch, and how do you dissect a problem to multiple subcomponents and then try to solve them one by one, has been a core competency, core skill of a undergraduate student in engineering for a while, right? But now, how do we materialize it? How do you actually try to achieve that? Is probably via skilling or mastering a programming language, and how to solve a problem, essentially, right? And how to get a problem to be solved in a more efficient way. So now with AI, the idea is that we can think it like that this way. So if we have a program, I mean, you need to know the syntax, you need to understand the what are the keywords of it, right? Then you try to use it to write a syntax. But then, of course, there was maybe tool tips, and there is IDE which were able to help you. Now we have something. Probably you can answer the ask the question from plain English, and it might try to assist you, right? So now the problem is, can you just write the full program with just plain English? You request what you need, and probably it will generate the entire code base for you, right? So that is a kind of a promise, or that is kind of a vision people have. So it's been dubbed as a vibe coding nowadays. I don't know whether you have heard of it. So it's like, you know what you need, but you ask AI to generate it for you. Then it might generate and probably deploy it for you, and then you can see how it feels, essentially, and try to modify it afterwards, right? So now, I mean, even school kids can do this nowadays. You can see, like, you can ask what you need, and it will generate it for you, right? So why not a school kid do that, right? So in fact, yeah, that should be the scale we need to have this disruption at. So after that, now as a fresh graduate or fresh undergraduate, what are the opportunities and what are the things you need to be capable of? So the first thing is that, of course, you need to adapt to the tools, but you can't forget the fundamentals, whether your problem solving skills, right? So the first thing is, like, that when you go to a job as an intern, for example, you might be given a specific task and probably asked to solve it first, maybe a toy project, right? But now, if you are capable of using these new tools, probably you will be able to solve them quite rapidly. But again, is it true? Like, yeah, the reason is that actually, yesterday, one of my students shared me with this result, actually experiment, which says that, in fact, if you give an experienced coder AI tool to use and support him, probably he will get distracted by it, and it will take more time for him to solve it, because he's probably distracted with this new tool, how to use it and so on. But of course, in future there will be, like, knowledge and know-how of how to use these tools effectively, and it might probably help you to generate low-level codes, probably a bug fix, and probably a additional feature, right? Can be done with general AI tools out there, right? So now, are we sticking into that particular tool set, and are we going to generate everything? But even though after generation, you need to make sure that it is what you actually expected, right? You have a vibe, you code it, it will generate the code for you, but you need to be able to read it and understand, then verify whether it is doing what you want to do. Then only you will be able to ask for a modification, right? So at that level, in associate software engineer level, probably, it will be much more easy to get things done, right? So now, if you want to go in the career ladder, like develop in the career ladder, you know that there are senior software engineer level, then maybe tech lead level, there are architectural level, right? Architects level. So where would you actually have a significant impact, and where would you need more thinking and more time to be spent, right? So of course, when the small maybe the bug fixing or coding testing activities, quality assurance activities, so these things get automated more and more, then you will have more opportunity to spend on actually designing systems, right? And actually framing real world problems, more and more real world problems in a situation where you can solve it, right? And actually provide solutions, right? So actually, I think that's where the future is, and probably in future, maybe 5 years, 10 years time, you might want to think about becoming a tech lead as your first job, right? Probably you need to learn about, of course, we are learning some of the software engineering principles, architectural features out there, what are the things we can do to build a software as a group, as a large collaboration, right? So now it comes a time where your team is a collection of agents, and you will just have to command them, and of course then you will have to rename, check their work and see whether they are doing it correctly, right? And maybe refine their work. So that's where I think that the future lies. And don't forget, still again I will reiterate it, it is critical to know basic problem solving skills nevertheless, right? It's not a there is no replacement for that, because you will have to know about let's say there is a subordinate under you, right? There's a subordinate, there's a group of engineers under you, then you still have to monitor them and give them feedback and make sure that they are doing the correct thing. That means it needs basic understanding of what is going on.
Yeah, very insightful, sir. So, do you think the traditional entry path, the writing code and fixing bugs, maybe shadowing seniors, is still as relevant, or AI is starting to do that better and faster?
Well, there are two aspects to this as well. For example, if you are building a code from the scratch, you are getting the idea out of the ground, right? That means you have your own freedom. It's a greenfield development you can do. Probably in that case, AI could be quite useful. It can generate, it can shadow essentially existing code bases, but start from a fresh ground. But software engineering is not always like that. There are a lot of existing code bases, there are a lot of legacy codes, legacy systems, and it's about mostly about integrating different systems, subsystems. So you can't just drop one subsystem and go ahead with the greenfield in most of the cases, right? So that means the expertise about that particular components, right? Whoever people developed it might have the best knowledge why it's some parts might need improvements, and why some parts cannot be touched upon, right? So you keep it as it is and you use it, because you know that if you try to disrupt it, you might have unforeseen consequences as a junior engineer. So that knowledge is quite important, and at the moment I would say that so shadowing a senior, for example, is still relevant, of course, you need to know about existing their strategies and so on. But in the future, again, it is about at what level, right? So at what level you will be having that exposure. So, I mean, most of the distributed software development efforts going on in the world, so probably you can go through code reviews and whatever the different maybe the history of the code, right? You can just observe how the system evolved over time. But that also can be, I mean, it is important still, and that also can be done more efficiently with probably with AI nowadays. For example, if you want to understand a specific aspect of the project, probably you can still go with that specific aspect and ask the AI or the maybe a co-pilot system for you, which it will probably give you the specific aspects of the project relevant to your specific query, and it will be much easier to follow through for that particular aspect. But yeah, so there are things which might be unforeseen. Like, let's say you want to do a change, right? Now you want to see how it will affect your system in maybe a larger scale. So you might want to update a certain field or maybe a specific part of the process, right? But now you might see that, okay, so the obvious straight up path is going to be improved by doing this, but what else will be affected, right? What are the dependencies? So yeah, so it's at the moment it's hard to predict how how it will go in the future. So we can hope yeah, it will improve certain aspects, but still we have to approach it very cautiously at the moment. So of course, over the time it will hopefully develop the confidence, and it will be much more efficient to get things done.
Yes, I couldn't agree more. If we imagine the future where AI handles most of the coding grunt work, could it make sense for someone's first role to be more strategy, something like junior tech lead?
Yeah, I mean, we have to think about it in a detail, right? For example, early days, like I mean, still now in some cases, right? Keeping books, right, was a specific job people has to do with manually updating things and so on. So the jobs will be offset, right? There will be offset in different jobs, and you need a different set of skills. So uh, within couple of years, like when the demand of the job is different, probably it's hard for people to adapt. So it should gradually happen so that you don't disrupt existing workforce and their lifelines, essentially their jobs, right? So it will gradually happen, I guess. But I mean, sometimes as it seems like some of the AI companies or AI solutions does not wait for that gradual transition. They are very rapid, and as I said, it is in exponential phase, right? So probably you need to think a little bit at a higher level, and again, not forgetting about the basics. You need to master the basics, but again, you have to think in terms of how do we uh, command these specific components of it, right? You have to think in modular level and architectural level. That's where like most of the problems comes in, but in industrial applications. But of course, there are components which are at lower problem solving skills as well. So yeah, this yeah, I could say that of course in future there will be junior tech leads, or maybe the name would stay as the senior or associate software engineer, but you would be doing the work at a tech lead level, but with much more efficiency, right? So you can get things done much faster. So uh, you will be dissecting and like doing a tech lead level jobs, right? So yeah, I mean, of course, there are like defined curriculum outcomes and defined graduate profile we have right now, but in the future it will also be evolving, and hopefully it will happen fast enough. And I hope that I mean, as individuals, you will also uh, adapt to that and probably get your profile in that level as well. Like you can generate a website with multiple functionalities, multiple business processes nowadays with maybe a couple of weeks time, where it took probably months or years in fast past in the past, right? Now you can get things done quite fast in that kind of situations. But again, the core engineering, how to manipulate the data, how to make it efficient, that kind of basics, basics, and of course engineering skills, you need to be more, I mean, you can focus more on those and get the things generated, the like mundane, maybe the business process automation, that kind of thing. You can get things done much faster with AI. But again, another aspect you can focus on is the designing of the interactions, right? For example, how the systems can interact with their users, right? Now, you know that most of the systems which is being built today, let's say the government systems, it could be a certain specific software system. They don't they don't materialize in real world. Their lifetime is quite short, and it does not achieve the potential it can, right? Why? The interaction design is probably not paid enough attention upon. Or it is like, essentially people, there are certain problems that as software developers or engineers, we don't care too much about that. We say that functionality is there, but the non-functional requirements of it, right? So maybe it is time that we pay more attention to that part, so that we can have like a sustainable and more long life software and essential systems solutions.
Yeah, it sounds a bit scary. But what would someone need to learn?
It is nothing to be scared upon, I guess. Of course, maybe a certain degree of being frightened is, it is natural in any type of evolution, right? So we are evolving, and it is probably natural. As engineers, you are better placed in a certain in the entire world's context, right? You are probably better placed to be the creators of these AI systems, right? But imagine the number of jobs which will be disrupted by just replacing some of the jobs. So I think as engineers, you have always some potential to contribute to development of these new technologies and use them as tools to do new things, right? So it is not that you are solving the same problem again and again, but try to solve new problems, try to frame new problems which can improve the entire entire human conditions, right? So identifying some of the problems and framing them properly, that should be the level the engineers should work. Because for example, in Sri Lanka, some of the engineers even after graduation, they are probably just stuck with some frame of work which is repetitive, and they are doing a technical level work sometimes, right? But they can probably also it is okay. It is like as a job, it is okay. Sometimes you are safe and you just have to do a very specific thing, and your responsibility is what you get paid for. So that is, it is understandable, but you should push to the boundaries. That's what I'm saying. Like, of course, maybe, it might be easy to push the boundaries now than ever before. So just harness that capacity, right? Why just do the same thing again and again when you can push the boundary at least a bit, right?
Yeah, thank you, sir. So, what would someone need to learn or unlearn to jump into that kind of role early?
Well, it is mostly about learning about new tools, right? In the practical sense, it is about learning new tools and how to use them effectively, and asking right kind of questions. right? So that's also very important. You have to ask, I mean, essentially it is about like when you have the I mean chat GPT or whatever the AI or large language model, if you can ask the right kind of questions, it is, I mean, people call it prompt engineering, for example. So and if you can ask the right kind of questions essentially and refine the question, sometimes you can't answer the question the like first time, but you can refine the question, right? Then you can I mean improve the way you can get things done. How do you ask somebody to do something for you, right? So that skill set, I think, would come in quite handy. And yeah, so in terms of unlearning, I think I mean, it's too early to too early for me to say that okay, you don't need this and you don't need coding skills, you don't need maybe a small maybe the algorithm design. I mean, definitely those will be there, and those will be important to know, because when there is a problem, then you are the one to solve it ultimately, right? Probably not the AI. AI cannot be held responsible, right? As a systems developer, as an engineer, so there will be a person who is held up on responsibility, right? That means you need to be able to dissect and maybe debug it and find the root causes. So those skills will definitely be remaining in the profile of the engineers. So yeah, so in terms of unlearning, again, maybe I mean, there is nothing to unlearn. The world is demanding more and more from you, I would say, but you have to learn about how to manage your time and your priorities, right? So it is like this, like when the world is demanding more and more from you, you have to decide where do you place your priorities, right? So sometimes it is about, I want to learn a very specific skill and master on that particular maybe a vertical, right? To a very depth of it. So that still remains a specific skill, and then you will be pushing the boundary of that vertical, right? But knowing the breadth of it, right? Knowing the what is the surrounding other areas, right? So that's also probably, I mean, important in the sense, like at a tech lead level, you know that you need to manage different aspects of a project rather than just one aspect of everything, I mean one thing, right? So again, the world is demanding more and more from you. So so you have to focus on what you want to do, and again keep the attention on specifics and breadth as well. So it's a challenge, I understand. And yeah, so I think you have to maybe I mean think about how do you and what you want to pay attention to, right? So it's some personal decision, and what kind of, I mean, more than just being skilled in a specific vertical, maybe you can learn a little bit additional about the breadth of it, how the system is coming together as a whole, and how it is solving a problem. And more than that, you need to highly pay attention to what are the problems and how do you identify a problem and how do you frame it in a way that uh, it is a problem which can be solved, right? There are problems which does not seem to have an answer sometimes, right? But framing such problems in a way that you can solve it, you can ask somebody to solve it, that's the skill, I think, in the future, which will be quite useful. And I mean, the idea is that if you can frame a specific problem and understand the specific problem people have and write it down essentially, then getting it off the ground is it could be quite easy to do rather than it was a few years or decades back, right? It is easy to get things done if you know the correct problem to solve. So yeah, unlearning, I will be cautious, but to learn, well, there are a lot of skills.
Yeah, thank you, sir. So, would it mean young engineers should focus more on system thinking, leadership, and decision making than syntax?
Definitely, yes. So the syntax is Yes, so syntax would, I think, move on to the maybe school level, I mean, maybe the O level, A levels. You can learn syntax, right? I mean, uh, so you have to think like, okay, so again, it is about your priority, framing a problem properly, right? So if you can frame the problem properly, if you can describe the problem properly, you can generate and probably understand the code, then you can test it. Even the automated testing, you can do that. And uh, as far as it is being solved, I mean, the idea is like this, think in this way, right? So for example, there, if let's say there is an entrepreneur, right? There is an entrepreneur who needs to get a problem solved, right? You have to think at that level. Are you going to solve it yourself, or are you going to recruit a group of maybe a software developers to do that, right? Probably you should prioritize on like framing such problems in a way that it can be solved by somebody else. So that skill is, I think, most of the Sri Lankan undergraduates lack, and we don't pay enough focus on that. So maybe it's high time that we focus on that level. And also, like as I said, the systems thinking, what do you mean by that, right? So the most of the time when you solve a problem, it is in a particular mindset, right? You know that advanced level question, okay, so we have the type of question and we solve it, and the answer is there, then we move on to the next question, right? But the system thinking is like this, like how whatever the system you are building, how whatever the solution you are giving can disrupt or can support or can change the other systems around it, other processes around it, right? So I think as Sri Lankans, we have plenty of examples trying to disrupt something, and then it kind of has a ripple effect across different aspects of life, even, right? Aspects of processes, aspects of various industries, and essentially even the economy, right? So but if you can understand a place to disrupt, if you can understand a place to maybe just do a minute change, and it might have a ripple effect across different industries, either for the best or the worst, right? So think in the consequences of what you are going to do, right? So and I mean, sometimes so that's important. And the other aspect of it is the leadership, right? So you might have a very maybe a insightful idea, and you might probably build upon that, and you might build a prototype, or maybe finally a project or something like that. But are you really going to, I mean, do you really believe in it, right? Then do you really want to get it into the hands of end users? So probably we are not thinking that much of that as young engineers. So I mean, sometimes it is just about getting an award or your degree, right? So I think we need to open up and probably go and do something which disrupt actual end users lives, right? I mean, it is us again, right? It is not somebody else. We are not probably developing systems for somebody else in somewhere else, but we need to develop systems for ourselves, right, to improve our lives. So that's where the leadership comes in, right? You have to prototype it, but why not get it done? Like, I mean, for example, if you really believe in your idea, it can solve the problem which you face, right? Then still you can find resources to solve it. For example, there are a number of investors out there who are trying to invest in solutions, right? So then if you can actually get that problem framed properly and build a prototype, which is relatively easy I mean, increasingly become easier. And I mean, it is not we are not talking about rocket science most of the time. It is something which can be built with existing technology, right? But still getting things off the ground and building things and deploying it and getting into maintenance of it, right? And getting the ball rolling, that's the main part which you need to uh, probably pay more attention on. So the leadership is also quite important. And I mean, everybody has idea, right? But I mean, there is no, you think that probably you are junior, and maybe the elderly will make decisions and what need to be happened, but we need to get out of that mentality. Elderly does not have the frame mindset or the uh, being, I mean, ability to use those tools as you can, right? You need to get the I mean, in exponential development, that's the way, right? The younger and the fresh mindset can always lead. So don't think the elderly are the ones to lead. It's you, right? It's the youngest and probably the one with the most fresh mindset can solve it. But again, be careful to ask the right questions and think in the systems manner, not just in a single vertical, but how it will affect, right? So you need to lead with exposing yourself to those problems as well. So it's a learning curve, but you can rapidly adapt to that, and that's where your potential is.
Yeah, thank you, sir. So this idea challenges everything we have been told, like start small, learn your way up. But if AI handle the small stuff, maybe we need to start thinking smarter, not smaller. So,
Yes.
how do you think universities and boot camps should prepare students for this shift? What is their role in this?
Well, I mean, systems thinking, again, I will refer back to that. The idea is that in the natural world, right, the systems develop or evolve and function by decentralized manner, right, most of the things. But in human world, like human hierarchy, we have a hierarchical thing, and somebody makes a decision and the others follow it, right? But in the natural world, it is more decentralized, right? So we are trying to get into this decentralized business all over again in the computer science, but again, there's a long way to go there. But in the systems, right, in the human built systems, engineered systems, so you can think of as individuals, right, how the other individuals can interact with you to get things done rather than following order also, right? So in a decentralized systems are going to be more efficient and more resilient and more sustainable in a way that it is not there in the hierarchical systems. So the universities will adapt, and definitely there will be a transitions in the way what we want to learn. But I mean, there's a specific curriculum built for the undergraduate students, and I mean, for doing research there is no restriction, so we have to balance between these two. So yeah, so in the universities, the major resource you have would be your colleagues, right? Of course, the staff is there, and maybe there are a certain number of resources, but your colleagues, right? Because as I said, in the systems thinking, the major challenge is to understand how this system or how these problems are affected. Maybe you have a problem, right? But is this problem common, right, to others? Is this problem have been attempted upon before, and what are the lessons learned, right? So usually when there is a failure, somebody might have attempted it before and might have encountered a problem, but he might not have published it somewhere, right? So he know what happened, but okay, so he has given up on that. But the next person comes in, he goes in the same path, usually because you don't communicate enough, right? So communication is crucial to understand. I mean, if you have an idea, right, you have to be able to, and you have to have resources to check whether is it a common problem, right? Do the other people also have the same problem? To what degree they have tried to solve it, right? and then what are the problems they faced, then you can try to get to the state of that problem solving, right? Solution, or seeking problem for that solution. And now the scientific literature used to be the state of the art, as we say. Still do, right? Peer reviewed scientific journals. But I mean, you see now it is too rapid. The evolution is too rapid to keep up with that. Even we have to refer to archive or preprint versions, and it gets cited quite a lot because the actual peer review process takes a long time. But I mean, you have Discord, and you have I mean, groups of people talking to each other, right? So again, with the caution and with open mind, but with caution, you have to be able to communicate and understand how common the problems are, and how common you can try to solve it. How I mean, you can get ideas and solutions and perspectives from different people. So this is why I said that maybe your colleagues who face similar problems are a resource. Consider them as a resource. Ask them questions. What are the problems you have? How can we improve this, right? So boot camps, again, maybe you can get together and try to solve one problem, but getting together and discuss about these things is important, right? So for example, like sometimes we have a problem, we ask somebody else to solve it. Maybe the government should solve it, or maybe I don't know, somebody else would solve it and we will use it, so we'll be happy. So we have to get a little bit out of that, and we need to get the leadership and the role of actually get things going, right? So you are the good at you are much better, you can be better at communications. And I mean, for example, a good example would be like the US government, right? So it's a huge like slow moving structure, right? If you want to do a change to that, it is quite tough to do. But if you want to automate a certain aspect, if you want to improve the efficiency of a certain aspect of it, right? You can still there is a community now in US which actually try to build systems as a community, right? Like a typical open source project, you can get together and design a solution. I mean, nobody says no. You can design the solution if the solution is sufficiently there, and if you can lobby for it, or if you can give the enough leadership to actually get it adapted into a government system. I think the opportunities are endless. You can make things happen by yourselves and as communities, right? So after all, it is all us. It is not somebody else who is doing things, right? So it should be the us who leads things and who get changes to whatever things we need, right? So yeah.
Yeah, so what advice would you give to someone who's unsure whether to start as a traditional developer or aim higher into product, AI coordination, or leadership tracks?
Okay, so I mean, being a traditional developer, I think it is still quite important that you get things done, right? So if you're given a task, okay, so you build this part, or fix this bug, or maybe improve this in this way, right? So that is important, but we don't know. There's a significant uncertainty at that level, probably. But there are a lot of tools available for you to do that, right? So the first thing is to adapt to use those tools. But again, you have to upskill yourself, right? To use tools, and probably to solve a little bit additional scope, cover the additional scope of maybe the user interaction part of it, right? So maybe for example, if there's a developer who does just the development part, there's a QA team, right? So probably you can get into do the QA part of it, and probably, I mean, there could be some specific, for example, let's say there is version control, for example, right? So there are a lot of such skills which everybody needs, and even though the software is written by itself, you can see like how the things are evolving, and probably you can those set of skills probably never goes away. It needs to be there, right? So, but think about a little bit different aspects as well. Try to upskill yourself, maybe go into deep into the algorithms side or deep into the AI side, right? So, there are a lot of learning materials, right? So if you are going to idle at just PHP writing, or that's going to get probably will get left behind. So upskilling is quite important for dev level, right? So problem solving skills will need to be like thought in a little bit advanced way, right? But then of course you think as a leader. Now, right now, today, you can deploy a number of agents and assign them tasks, right? So if you can do that, why keep coding yourself? So again, those skills about like reading and debugging and maybe suggesting a upgrade to that, maybe the performance upgrade. Probably you have the experience on doing these things, right? Maybe the security aspect of it, how to write it the best way, right? So maybe you think that you are doing something the finest way, but there could be other ways, right? So yeah, so maybe I would say that open the eyes and try to see what other people are doing and what are the resources out there, tools out there. Then upskill yourself one way or the other. And in long term, I don't think it will go away. It will remain as jobs for a certain time at least. But problem solving, that's the priority for any of the engineers in future. Problem framing, and then putting it to words, and then of course there are the systems aspect of it, non-functional aspect of it. You have to think more about. If you can actually think about the non-functional aspects, the functional aspects will probably somewhat fall into place again, subjected to your verification. So you see what I'm trying to say.
Yeah, that was a stunning discussion. I hope our listeners have enjoyed the session as much as myself. So, thank you so much for your insights, Dr. Chaturanga. Finally, I would like to ask if there is anything you need to add to our episode which has missed from our end. I would like to give you the opportunity now.
Okay, so yeah, thank you for organizing this IEEE TechVerse, and Chamali for the interesting questions and the discussion. So, what I would add is that in the future, it's whatever I said now up to now, right? So it's more about excitement and uncertainty about exponential growth, right? So the uncertainty is there. So, but there has been certainty for a long time, and there has been development a long time. So in this case, it is mostly about your jobs get refined, right? They get reshaped, and you adapt, right? If you can adapt better, you will survive better, right? So that's the law of the nature. So try to adapt, and also be aware that sometimes it is just, maybe 90% of what is going on could be a hype, right? So that also comes under the uncertainty feature. But in exponential growth of the entire thing, the uncertainty and the hype is sometimes quite hard to distinguish. but yeah, so again, you have been asked to do more, so with more tools, right? So it's a balancing act. So try to think what matters to you ultimately, right? What problems you need to solve, and what could be the things which, as engineering solutions, can help you. That's the main focus, and not just the job and not just the salary, right? So salary would the money would come if you actually solve the problems which people have, right? So yeah, so that's the suggestion I have, and yeah, wish you all the good luck, and hopefully the future will be brighter and better than this. So yeah, thank you.
Thank you, sir. I'm glad that you brought that incredible point up. So, thanks again, sir, for sharing your valuable knowledge with our audience. It was an eye opening conversation, I would say. It's clear that in the age of AI, our definitions of entry level might need a full reset. So maybe tomorrow's first job won't be just writing code, it might be learning to lead the coders, human or not. So, again, thank you so much, Dr. Chaturanga, for joining with us to enlighten our audience and give them a heads up about what the future holds for them. So, thank you, listeners, and stay curious and keep rethinking what's possible. Have a great day.